Welcome back to another video on using PixInsight. In this 9th video we're going to look at processing a galaxy image, in this case the famous Andromeda galaxy. And while it's a very popular target and it's particularly beautiful, it does pose some challenges to the newcomer. One of which is the very bright core of the galaxy here, which can easily clip on even modest exposures, and at the same time the very faint periphery of blue and nebulosity in the far corners, which often escape those same medium exposures. This might look like the final result, but we're going to start with far more meagre means. So I'm just going to remove that for the moment and take a look at what we start with. Here I have a number of different stacks. I've got 3 luminance stacks at different exposure times. I have a hydrogen alpha stack to see if there's any nebulosity which is worth picking out. And then on the right hand side I've got red, green and blue stacks. So obviously here I've taken the images with a monochrome camera with separate filters. The reason for 3 luminance stacks is quite clear to see in these unstretched images. You can see that the core of the galaxy is clipped here, and that's on a 600-second exposure. At half that it's just clipping in the middle, and halving it again I've at least got things in the linear range of the sensor. So one of the things we're going to do, which will be novel here, is I'm going to combine these 3 luminance images to make one luminance image that will have a very high dynamic range, that will not only capture this inner core but also the very faint periphery. The stacks all have got the suffix DBE. That stands for dynamic background extraction, because where we have left off with these stacks is we've obviously gone through the calibration process in each case, and because of sky gradients I've done a dynamic background extraction to even out the background. The hydrogen alpha may bring out some nebulosity, and for the moment I'm just going to shrink that down because that's probably an added confusion at this point. And the red, green and blue are going to be processed as normal, in a sense of creating a colourful, slightly diffuse image that will then be combined with luminance, just as we did with the M31 image. But one of the things that we also will take a look at here is that we've up to now been using colour images to do colour final images. With these monochrome red, green and blue stacks, what I'm going to do is show you some techniques to combine them to get a sensible colour balance quite quickly. But for now we're going to take a look at luminance and how to combine them so that we create a high dynamic range image without any clipping. Before combining them into one image, it's useful to take a look at them up close with a screen stretch. They do look remarkably similar, but when you look up close you'll notice that the shorter ones have a poorer signal-to-noise ratio in the background, and even in some of the midtones as well. And so while you could technically integrate all your sub-exposures of all the different lengths together as one master luminance, which would improve the signal-to-noise ratio in the margins, the problem will still remain that it won't fix clipped highlights. So what we're going to do here is spend most of my imaging time with the exposure plan accumulating 600-second exposures, and then maybe a quarter of the time with 300 and even less for the 120, on the basis that really with the shorter exposures I'm only worried about bright parts of the subject, and so therefore they inherently have a better signal-to-noise ratio. To combine these images we need to make sure that these images here are on the disk as a file, which in this case they are, and we're going to use one of the integration processes. So under image integration there is one called HDR composition, and I've loaded it with the 3 files that are on the screen at the moment. As is typical with PixInsight, there are a number of different options, one of which is to work out which files represent the strongest exposures and which the weakest, and how to blend them. That typically is worked on by having the top one of the stack being the brightest and then getting progressively dimmer down the line, unless in this case you have the exposure times not only in the file name, but also, more importantly, in the FITS header. So this checkbox here, Automatic Exposure Evaluation, looks at the FITS header and works out the order of these images and how to process them. One of the perhaps the most important parameters is the binarizing threshold, which is really the point at which one file takes over from another, and it's on a scale of 0 to 1. Typically somewhere around the point 7 is where I normally keep it. And these little options down here do allow you to change the smoothness of the mask that the system automatically generates to reduce any obvious steps between images. And these two down here, mask growth and replace large scales, does enable you to sometimes preferentially look at things other than just their intensity, but for instance to process small points of light better than, say, galaxies. So that, for instance, as soon as you start getting above 0 here, you start to block out large galaxies in terms of this process and control your emphasis on things like bright stars. But in this case we're particularly after the galaxy core, so leave that at 0. A couple of other little things. There's generate a 64-bit HDR image. So if you have a very high dynamic range image, this is sometimes useful. In this particular case, because also I don't want to necessarily generate a 64-bit image throughout the rest of this video, which tends to slow things down a bit, I'm going to just uncheck that, and I don't need to see the masks because I trust what it's doing. So I'm just going to go ahead and run it. And it will create these masks that combines the sets of images and then create a new image that hopefully will have not only the benefit of the shortest exposure on the core, which you can see there, but also when I expand it up and do a screen stretch and roll out to the side, I've got good signals noise ratio in the shadows. So the nice thing is when I look into the core and look at the core values, you can see at the bottom that I keep the core values within a sensible range and I don't blot them out and lose the detail. And while it looks quite bland at the moment, because the signals noise ratio is good, we can tease out the details at a later stage. Let's make a start at stretching this image to give us some interesting information. So I'm first of all going to look at the whole image, and you notice it's screen stretched at the moment, and as before we're going to use a combination of histogram transformation and masked stretch. So I'm just going to remove the screen stretch and bring up intensity transformation, histogram transformation, and equally masked stretch. Starting with the histogram transformation, reset the controls, bring on the preview, and I'm going to stretch it. And you see the core comes up pretty quickly, and you have to do a pretty extreme stretch and before you start seeing the galaxy as a whole. So I'm going to leave it around there and apply it. Then I'm going to close down the preview, and I'm now going to use the masked stretch. If I look at that now and look at the dark region around the background, we've got a value about 0.08, something around there. So I'm going to change my upper limit to 0.1, leave the others at default and apply it. Notice there's no green bar here, so this is the image in its reality, in its nonlinear state, and you can see that we've started to pick up the full extent of the galaxy into the corners, and you can see the other two galaxies here as well. And then zoom into the middle, you can see that the core has started to become a little bit singular, and there are a few dust lanes coming in, but they're not very distinct. So I'm going to show you a way of making the dust lanes in these bright areas more distinct. So I'm going to shut that down for a second and bring up a new tool. This tool is under the multi-scale processing tools, and it's called HDR Multi-Scale Transform. Another mouthful, but basically it allows you to change the distribution of tones at different scales, and it can improve detail. There is no preview on this. What we can do, for instance, is draw a preview window and take a look at it. So if I run the default parameters over that you can immediately see that it picks up the dust lanes and it makes the core a little bit more intense, but the dust lanes now start coming into the core area. That looks fairly attractive on this scale, but if you go to the full one and apply it, it's quite a quick process here. You see that the galaxy more or less disappears, and this leads us to yet another trick that one can do. First trick is, I'm going to actually repeat this but using the median transform. It gives a subtly different result. Now, I can't explain to you why the result's different, and this just emphasises the point with PixInsight that you just need to experiment and try things out. So if I, for instance, drag a clone of that down there, and then go back and try this with median. Okay, so if I drag that over there, drag that over here, shrink that down, subtly different result. I don't know which one you prefer. It's a matter of personal preference. But what I'm going to do is not use these in their entirety. I'm going to actually use them in combination. So for instance, on this one, if I roll it back to the normal galaxy, I'm going to blend these two images together so I get a bit of everything. And the way I'm going to do that is to use a new tool that we haven't tried so far called Meth. Meth is not the best documented feature of PixInsight, but at the level I use it, it's fairly straightforward to use. And it's under the process, and it's got its own little tab called Meth. And what it allows me to do is, as the name implies, it allows me to create mathematical relationships between images and create new images. So for instance, I can add two images together, or I could subtract one from another. And when I talk about add and subtract, I'm talking about the pixels themselves. Clearly when you add things together, you can clip, because if you add two 0.8s together, you get 1.6, which is clearly clipped. So for instance, let me first of all go into something called the expression editor, and this allows me to construct a very simple mathematical relationship. And if I look at my images and I click on my clone image and then hit the plus button, which is on the keyboard, and then the other one, that will add the two images together. Now that will add them together at equal weighting. If I wanted to add them with different weighting, I could, for instance, say I want to times that by 0.7 and then times this one by 0.3. So I could do 70-30 and things like that. So I'm just going to remove that for a second. Now obviously adding fractions of the image values together wouldn't clip in that case, because 0.7 plus 0.3 is equal to 1. There are easier ways to stop clipping. So if I simply just add the two together, and then this pass button just tells me whether there's any errors in my equation, and it says no, everything's fine, it's telling me what's going to happen. Hit OK, and down here I want to create a new image and rescale the result. So when I rescale the result, it will scale it back down to the same range of 0 to 1 and stop clipping. I can also give it an ID, so I can say combined HDR image loom and hit OK, and it immediately does the math. So I close that down for a second, and what I now have is something that's subtly different to the pair of them. So it has a bit more extent on the galaxy, goes out further, and it still has that subtlety of the middle bits with these core values here. And you can play with this endlessly to get the right balance. But for now, it's quite a good demonstration of the technique. Very simple Meth equation. And there are others as well, which are quite entertaining, that will come on later on, especially when putting in star colour. I think there's also another underlying truth here, that some of the manipulations that you apply to an image to improve it sometimes creates other issues, or perhaps goes too far. And so creating a duplicate of an image and processing it slightly different ways and then combining the two back together again allows infinite subtlety and get the best of everything rather than having to compromise on one thing to improve something else. I'm going to quickly close down these two images and carry on working with the one in the middle. And I'm going to shrink these two down as well because I don't need these anymore. And tidy up the desktop by doing Window, Arrange Icons, and they all go down to the side here. And just as you can start to see, we've now got a number of images that are all starting to occupy quite a bit of space. And so that we don't lose control over what we've done or be able to roll back, the good idea is to save a project. So here you do Save Project and you type in your project details, and all the states that you have in your image and all the history states are all preserved, which means that you can come back to it another day and either undo and unpick, redo and so forth. I'm not going to go through that because this project is already being saved in the background. So I'm going to bring up another new tool to look at other ways of stretching an image which are quite useful. But the first thing I'm going to do is turn this poor little thing the right way up because it just looks stupid this way around and it just makes me laugh. So I'm going to do fast rotation and I'm going to do 180 degrees. That's an improvement because I have the darker parts on the underside of an image which to the brain it feels the right way around, doesn't feel like it's upside down. But I prefer an image to read bottom left to top right, which again is a convention, and although it's technically not correct because I'm distorting nature, this is all about making pretty pictures. So I'm going to do a horizontal mirror. And obviously when I come to process and combine other images like the red, green and blue, I need to make the same manipulations again, otherwise I'll get a very strange result. So that to me looks dynamic, it reads nicely as an image, and I'm going to show an alternative way of emphasizing structures and a way of stretching at very large scales. This uses a new tool which we haven't seen before. It's still under the Intensity Transformations tab and it's called LocalHistogramEqualisation. What this tries to do is look at areas of your image and boost local contrast to the same degree so that it equalises the contrast, the local contrast in different parts of your image, and it does it at different scales. The kernel radius at the top in effect is the scale. The amount of contrast that it changes is this middle slider, and you can back off from the full amount to give a more subtle approach. The last one here, called histogram resolution, obviously when it analyses what contrast already exists in your image, it looks at a histogram of the local area, and it can be either very fine at 12-bit or it can be coarse at 8-bit. And what you will find is that since you're boosting contrast, this control here will have a quite devastating effect on the outcome. Let me show you this with the preview. So for instance, this is the kernel radius of 64 with the default settings, and it's produced quite a dramatic result. If I toggle the preview on and off, it's pretty awful, even with the default values. If I go to 12-bit, it makes the result even worse and clearly unacceptable. When you're using a small kernel radius, I would say under 100, I would use the 8-bit control, and I'd also back off the amount to give a result that's a little more natural. Because you can always do this iteratively to build up to the right level, and you don't have to do it at the same scale. And what I do is use this in two forms. What I typically do is start off with a big kernel radius, something about 350 or so, and normally an amount of about half, and I back off the contrast by a little bit, about 1.5. So not too extreme. And if I look at what it does, if you notice, it very subtly extends the galaxy into the edges. And it's a very good technique when you have either a nebula or a diffuse outer glow of a galaxy to emphasize that structure. Now that is okay, but I'm using an 8-bit histogram. When I'm at big kernel radiuses, I tend to use a larger resolution, because what it can do then is pick up a much finer variation in contrast in the outer field, and it gives a far subtler result, and it won't necessarily emphasize noise. So what I'll typically do is do one at this level. So if I toggle on and off, you can see that all this faint stuff around the outside is very subtly improved, and if I just increase it slightly to full 100%, you see that even more so, how it brightens everything up. So I'm going to back off a little bit and hit apply. Now when you use 12-bit histogram resolution, it does take a few moments, so I'm going to apply this and then come back when it's finished. Okay, with that done, what I'm now going to do is back off to a much smaller radius, around 60 or 70, and back to a histogram resolution of 8-bit. And what I'm going to try and do is emphasize some of the smaller structures. So here, while the gaseous clouds and the faint periphery of the galaxy here aren't really changing much, what it is doing is improving the dust lane definition. So again, I'm going to apply that, and at this histogram resolution it's quite a bit quicker. So there we have it. I can close my preview down, and if I zoom in to half-life size and back off to, you can see the effect. Quite subtle. I haven't blown the cores out. I've got details of these dust clouds going right into the central core. If you remember rightly, when we went back to the original image, this was just one wash of pale grey, and that's quite pleasing. But what I might like to try and do is reduce the emphasis of the stars, because while the stars aren't particularly bad in this image in terms of being bloated, when you look at the image as a whole, the stars are quite dominant. So in the next little section of this video, I'm going to look at a method of making the star sizes slightly smaller.